Hi, Mr. Holding. This is Mr. Holding, sorry. And this video is just looking at distribution of scores again, but when you've only got an upper limit. So if it says like what's the percentage of something above a certain point or below a certain point. Okay, so we're going to look at question 11 from chapter 11C, and it says the distribution of IQ scores for the inmates of a certain prison is approximately normal. So the distribution is normal, with a mean of 85 and a standard deviation of 15. Okay, so there you've got your information. We'll write them down in a second. A, what percentage of this prison population has an IQ of 100 or higher? All right, so in terms of our variables, if I just go back here as an example, our lower is going to be 100 because it says 100 and above. All right, so 100 will be our lowest point. The upper limit, that's where it gets tricky because it doesn't tell us an upper. All right, so we need to assume that it's everything above 100, so maximum score. So the trick is when we put it in, we're actually going to put an upper limit well above whatever is possible. So it might be the highest IQ, let's say it's, I don't know, 200. We're going to put in 2,000 because we want to include every possible IQ score above 100. Okay, second one, if someone with an IQ of 70 or less can be classified as mentally disabled, what percentage of the prison population can be classified as mentally disabled? We're going to do the same thing, but the opposite. So the highest score is going to be 70. The lower is going to be lower than the lowest possible score. So we're going to go right down below 0. Okay, so what I'll do is I'll set this up and we'll keep going. Up the variables I've got so far. So I've got my average of 85 and my standard deviation of 15. Okay, question 1 wants to know the percentage above 100. Okay, so I'm going to use my calculator and I'm going to go stat mode, and I'll do it at the same time over here. I'm going to go distribution, I'm going to go normal, and I'm going to use NCD because remember we're still after a range of scores, not a single specific one. It's anything above 100, so that's still a range. We'll just fix that. All right, so I'm going to go NCD. Now I'm going to go put in my variables. I've listed my variables. That's important. I've listed them down. So my lower value is 100. Remember, I want what is above. So my lower one is that limit, 100. My upper, I've said 2,000 here. It can be 1,000,000. It can be 1,000. You just got to pick a number that you know is higher than the highest possible score. You may not know what the highest possible score is, so just make a number up which you think is just so extreme that it's never going to happen. I reckon 2,000 is fine. I'm going to go, my standard deviation as told is 15, and my mean, which is that funny U thing, is going to be 85, or my average is 85. From there, I'm going to go down to execute. I'm going to hit F1, and it's going to calculate. Okay, so therefore, the probability of a score above 100 equals 0.15865525. So I write that in, which is approximately 15.87%. Okay, so that's roughly that. All right, now that's A. B is the opposite. Okay, so I'm going to use these same things here, but B asks me, and I've lost it, there it is, if someone has an IQ of 70 or less. So in that case, 70, I'll just press exit and go back. It's got the same standard deviation, the same mean. My upper is going to be 70 because it's asked me 70 or less. Now we might go minus 100. Okay, and go back down, hit execute and calculate, and there we go. Okay, it's a probability of 0.15865528. It's very similar, which is about 15.87. Yeah, 15.87% again. Okay, so that's the percentage, the percentage likelihood of that. I won't go through writing it all down because it's exactly the same, but the two that you swap are these. Okay, so your 70 goes in there, and then you pick up a number that's got to be well below the lowest possible score. Okay, you don't just go lower than 70, you go the lower possible so that you account for everything on the normal distribution scale below that point, or above that point if it's higher than. Okay, so hopefully you found this helpful. Good luck with it.